Hello everyone, welcome back. In this video, we're going to summarize the ANPR project that we've been discussing about in a couple of weeks. In this video, the end result will be something like this. Check out this command. We're running a Python program to detect and talk to Arduino. We have the weight as best.pytorch pt. This is the image size, and this is the confidence, 0.9 or 90%. We have this test video stored in data videos as test1.mp4. So when we run, whenever we detect a known numplet, we send one to Arduino, and Arduino has been programmed so that when it receives one from the PC, it turns the LED on. This is the LED. Here is the LED. So let's run the program and let's see what happens. Okay, so let's check the LED now. Seems the LED is on for a long time. So let's check what's happening. What's happening? LED, the Arduino is receiving one for a long time, but also 0. So when the LED blinks, it means a plate number is detected, and when the LED is off, it means we are getting 0, 0, 0s. In the future, instead of LED blinking, we'll use a servo motor or a stepper motor to act like opening the gate. And in real life, a mechanism to open the gate is triggered by this same signal, the same signal that's triggering the LED. Okay, this is the end result. But how do we get there? That's what we're going to discuss in the entire video. Okay. Luckily, I have everything well set. This is the repository called end-to-end ANPR. Okay, so let's start by cloning. Okay, the project is cloned locally. So what we do, we're going to check the instruction on README. This is the README. We are at this step. We have cloned the repository locally. Then we get, let's navigate into the repository. is what we have. Let's check the next instruction. The next instruction is to navigate in the folder or the directory known as data processing. CD data processing. This is what's inside the data processing. That's LS works better. This is what's inside the data processing. So what we have? We have 3 raw footages, and we have tools, tool 1, tool 2, tool 3, tool 4. Let's check the next step. Once we are in the data processing, we're going to start turning the raw footages into images. So let's start by this one. We're turning, okay. So it says the frames were saved in the folder named frames. It was not there, it was automatically created. Let's check. There is frame. Let's check what's in the frame. In the frame, there is now 264 files, images. So then the next video, it is the next video. Okay, then the third video is the third video. Okay, so let's check what's in the frames now. 3 frames, 491 files. Okay, there is a tool. If you check here, there's a tool. The second tool is for reviewing the images. So we can have a look at those images by Python tool 2.02. Let's look in the frames. Okay, so you can look in the frames. Use the viewer, so we can have a look in the frames. N is the next, P is previous, X is to delete, Q is quitting. Okay, press N to check if the files are good. So I quit. The next instruction is now labeling. We have pictures, they need to be labeled. Our frames are here. Here are the frames. we don't have labels yet. So let's label them. The instruction says you can use label image. So label image is here. I include the label image in the tool and I customized it a little bit. So I open label image. Okay. So let me open the directory. Here is the directory. Okay. So I start labeling the images. I created the bounding box and the class is RAG220P. It's the first class, and I save and go to the next image. I zoom it. The next image, it's in the same class, so I do OK and move. Okay, so I go next. When labeling is done, the next tool is to rearrange the dataset. In the YAML file, as you can see in the YAML file, we have the number of classes we are targeting. And brief, this is to indicate where the images are located. So we have a tool here, tool number 4. Tool number 4 will do this rearrangement. So let's run to number 4. We rearrange the dataset. Dataset should be rearranged now. Let's check. There is a newly created folder called dataset. It was not there before. When we did ls list previously, it was not there, but now it's there. So let's look into it using tree dataset. Okay, it's created and it's structured like this. Okay, so now we are ready for training. Okay. So the training starts. This It's going to take a while. Mhm. Almost an hour. So these weights, last and the best, they have the same size. Then this is the summary. Look at the summary. The summary shows that the map between 50 and 95% shows that the best model is this one, RAH2130, followed by RAG.20P, then this one. It says the results are saved here. So let's get there and see. Neurons, trend, experiment 2. In the weights, we have best and last. This is where the knowledge is packed. What the model has learned is packed here. and this is the best one. This is what it had as last. Okay, this needs to be seen visually. Let's go there. Let's look at the confusion matrix. Here is the confusion matrix. Not bad. 1, 0.85, 0.99. 1. Background. Background means where there is no object. The model needs to know the difference between where the object is located and where the object is not located. So this means it knows that difference. That's good. This happened when it was learning and trying to evaluate itself. This is the precision it had. Okay. Looks good. Let's now detect. Oh, let's talk to the Arduino too. I pasted. Okay. So it's in the experiment number 2. We are using the knowledge from experiment number 2. Okay. Okay. Result is saved in run to detect exp. For let's go there. In detect. Okay, let's watch this video. Well done. So that's it. Yeah. See you in the next videos. Bye.